Hi, good morning, sir, and as well as to my classmate. So my name is Jesus Candidato, and I will continue the second part of our report all about the Earth-like planets, Venus, and Mars. So Mars is more interesting to most people than Venus because it is more hospitable. Mars is more welcoming than Venus because its atmosphere allows us to investigate more and further, unlike Venus. So even from the distance of Earth, we can see surface features on Mars and follow the seasonal change in its polar caps. Although the surface today is dry and cold, evidence collected by spacecraft suggests that Mars once had blue skies and lakes of liquid water. So even today, it is the sort of place we can imagine astronauts visiting and perhaps even setting up permanent bases. So this is photographed by the Hubble spacecraft, photographed by the Hubble Space Telescope, and this is one of the best photos Mars taken from our planet, obtained in June 2001, when Mars was only 68 million kilometers away, so it's closest to Earth. The resolution is about 20 kilometers, much better that can be obtained with ground-based telescope, but still insufficient to reveal underlying geology of Mars. Next is the spacecraft. Next is the spacecraft exploration of Mars. So Mars have been intensely investigated by spacecraft. More than 50 spacecraft have launched toward Mars, but only about half were fully successful. So it means that 25 lang yung naging successful maybe. And the first visitor was the US Mariner, which flew past Mars in 1965 and transmitted 22 photos to Earth. By then, newspaper headlines Saudi announced that Mars was a dead planet. So, from the discoveries of this US Mariner 4, from the 22 photos that it transmitted to Earth, Mars looked so dead that time that it didn't have something that resembles life. But in 1971, with the NASA's Mariner 9, became the first spacecraft to orbit another planet. Geologically, Mars didn't look so dead after all. So, with the NASA's Mariner 9, the spacecraft or the space discovery mapped the Mars, and after that it discovered that it has something like volcanoes, something like channels that makes Mars even more alive. And next one is the twin Viking spacecraft of the 1970s, were among the most ambitious and successful of all planetary missions. So two orbiters surveyed the planet and served to relay communication for two landers on the surface. So the twin Viking spacecraft has its two orbiters, which is two spacecraft orbiting the planet, and the Viking 1 and the Viking 2 landers, which land directly on the planet Mars. So the Viking 1 lander touched down on the surface of Chris Planitia, or what we call the Plains of Gold, on July 20, 1976. So this is what Chris Planitia looked like. As we can see, it's pretty similar to Earth. So 2 months later, Viking 2 landed with equal success in another plane farther north called Utopia. So while Viking 2 landed in this area, okay. So Mars languished and visit for 2 decades after Viking. So 2 more spacecraft were launched toward Mars, by NASA and the Russian Space Agency, but both failed before reaching the planet, so it's too bad. The situation changed beginning in the 1990s as NASA began a new exploration program using spacecraft that were smaller and less expensive than the Viking. The first of the new mission, appropriately called the Pathfinder, it landed the first with solar power rover on the Martian surface on July 4, 1997. And that time, an orbiter called the Mars Global Surveyor, or MGS, arrived a few months later and began high-resolution photography of the entire surface over more than one Martian year. So this is the Mars Global Surveyor. These missions were followed in 2003 by the Mars Odyssey Orbiter and ESA Mars Express Orbiter, both carrying high-resolution cameras. A gamma-ray spectrometer on Odyssey discovered a large amount of subsurface hydrogen, probably in the form of frozen water. Subsequent orbiters included the NASA's Mars Reconnaissance Orbiter to evaluate future landing sites. So Maven studied the upper atmosphere in India. Mangalayan also focused on study of Mars' thin layers of air. Several of these orbiters are also equipped to communicate with landers and rovers on the surface and serves as data relays to Earth. So this is the NASA's Mars Odyssey Orbiter, and this is the ESA Mars Express Orbiter. So these orbiters orbit the planet and serves as the mapping object to allow and navigate the landers in the planet Mars. Right. So, and after that, in 2003, NASA began a series of highly successful Mars landers. So, this is the time where the NASA have a high chance of successful Mars landers. The twin Mars exploration rovers, or the MER, named Spirit and Opportunity, have been successful far beyond their planned lifetimes. The design goal for the rovers was 600 meters of travel. In fact, they have traveled jointly more than 50 kilometers. So, yung design lang nila is 600 meters. Pero, they traveled more than 50 kilometers. What a great opportunity. So, after scouting around each realm, Opportunity drove down the steep walls into an impact crater called Victoria, then succeeded with some difficulty in climbing back out to resume at its route. So this is the Victoria crater, and the Opportunity drive past its walls, which is pretty commending. Okay, this is the Victoria crater, as you can see. So dust covering the rover's solar cells caused a drop in power, but when a seasonal storm blew away the dust, the rovers resumed full operation. In order to survive winter, the rovers were positioned on slope to maximize solar heating and power generation. And in 2006, Spirit lost power on one of its wheels and subsequently became stuck in the sand, where it continued operation as a fixed ground station. So, the Spirit sadly became stationary because of the problem on its wheels. Okay, that time. And meanwhile, in 2008, Phoenix, a spacecraft reborn of spare parts from a previous Mars mission that had failed, landed near the edge of the North Polar Cap at latitude of 68 degrees and directly measured ice in the soil. Next is, in 2011, NASA launched its largest and most expensive Mars mission since the Viking. So this is the 1-ton rover Curiosity, the size of the subcompact car, has plutonium-powered electric generators so that it is not dependent on sunlight for power. So this time, they've improved the rover, which is ito na siya. You look at this. We have it have too many wheels. 1, 2, 3, 4, 5, 6. 6 wheels. Curiosity made a pinpoint landing on the floor of Gale Crater, a site selected for its complex geology and evidence that it had been submerged by water in the past. So previously, Mars landers had been sent to flat terrains with few hazards as required by their lower targeting accuracy. The scientific goals of Curiosity include investigations of climate and geology and assessment of the habitability of past present Mars environments. Yon. And in 2018, the NASA's InSight lander, touched down on Mars carrying a suite of scientific instruments. These include a package named the Mole, that will dig into the surface of Mars 1 millimeter at a time, hoping to reach a depth of 5 meters with heat sensors. So neither of these missions carries a specific light detection instrument. However, so far scientists have not been able to devise a simple instrument that could distinguish living from non-living materials on Mars. So this is the NASA's InSight lander, and it carries an instrument that could dig. So it means that this this lander is made for examining the soil, and it digs up to will dig up to 5 meters with heat sensors. Good. The focus on the possibility of life returned with the 2020 launch of the large rover Perseverance. So, eto na yon. Perseverance. So, it improved, di ba? As we can see, it is more, it is huge than the other one. And we can say that have too many new things on it. So the near twin of Curiosity, so it is the near twin of Curiosity, but it is more improved than Curiosity. It landed in a former lake bed, and part of its mission is to drill into ancient sedimentary rocks and collect small samples of these rocks to be returned by a later mission to Earth for laboratory study. NASA's remarkable helicopter drone named Ingenuity has acted like an airborne scout for this mission. So, it is accompanied with the Ingenuity, which had acted like the scout. And this is the lander. And let's come up to the Martian samples. Much of what we know of the Moon, including the circumstances of its origin, comes from the studies of lunar samples. But spacecraft have not yet returned Martian samples to Earth for laboratory analysis. It is with great interest, therefore, that scientists have discovered the samples of Martian materials are nevertheless already here on Earth. Available for study, these are all the members of a rare class of meteorites rocks that have fallen from space. So sadly daw, there is no Martian samples came from the Mars planet itself, carried by the spacecraft or anything, but with the curiosity of the scientists, they discovered that Martian materials or the Martian samples are here on Earth. Martian samples in the form of meteorites. Yan. So many impacts have occurred on the red planet, as shown by its heavily cratered surface. Fragments blasted from large impacts can escape from Mars, whose surface gravity is only 38% of Earth's. A long time later, typically a few million years, a very small fraction of these fragments collide with Earth and survive their passage through our atmosphere just like other meteorites. So, rocks from Mars comes collide with Earth and survive their passage through our atmosphere. So most of Martian meteorites are volcanic basalts. So these are most volcanic basalts. Most of them are also relatively young, about 1.3 billion years old. How can it be young? So it's 1.3 billion years old. The Martian origin of these meteorites was confirmed by analysis of tiny gas bubbles trapped inside several of them. So it is how they found out that this is a Martian sample. These bubbles match the atmosphere properties of Mars as first measured directed by Viking. And one of the most exciting results from analysis of these Martian samples has been the discovery of both water and organic carbon-based compounds in them, which suggests that Mars may once have had oceans and perhaps even life on its surface. As we have already hinted, there's other evidence for the presence of glowing matter on Mars in the remote past and even extending to present. So um, these um, these things resulted to the analysis that somehow there have been water on Mars. And we go to the global properties of Mars. So the global properties. So Mars has a diameter of 6,790 kilometers, just over half the diameter of Earth. Yon. Its overall density of 3.9 grams per centimeter cube suggests a composition consisting primarily of silicates but with a small metal core. The planet has no global magnetic field, although there are areas of strong surface magnetation that indicate that there was a global field 5 billion years ago. Yon. Apparently, the red planet has no liquid material in its core today that would conduct electricity. So electricity is not available, will be not available on Mars because it didn't have something as a liquid material that can conduct with electricity. So thanks to the Mars Global Surveyor, we have mapped the entire planet. So um, from the beginning of the lesson, we talked about the Mars Global Surveyor, and this is how Mars map look like from the Mars Global Surveyor with the laser ranging. Yan, ito siya. So it based on their altitude. Their color is based on altitude, which is starts from -8 to 12 in kilometer. And approximately half the planet consists of heavily created highland terrain found primarily in the southern hemisphere. The other half, which is mostly in the north, contains younger, lightly cratered volcanic plains at an average elevation about 5 kilometers lower than the highlands. So remember that we saw a similar pattern on Earth, the Moon, and Venus, a geological division into older highlands and younger lowland plains seems to be characteristic of all the terrestrial planets except Mercury. Yeah. Lying across the north-south division of Mars is an uplifted continent the size of North America. This is the 10-kilometer high Tarsis Bulge, a volcanic region crowned by four great volcanoes that rise still higher into the Martian sky. Next is we'll talk about the volcanoes on Mars. So, yeah. So the lowland plains of Mars look very much like the lunar Maria, and they have about the same density of impact craters. Like the lunar Maria, they probably formed between 3 and 4 billion years ago. Apparently, Mars experienced extensive volcanic activity at about the same time the Moon did, producing similar ballistic lava. So it has high volcanic activity, the planet Mars. And the largest volcanic mountains of Mars are found in Tharsis area, although smaller volcanoes don't that much of the surface. The most dramatic volcano on Mars is Olympus Mons, or the Mount Olympus, with a diameter larger than 500 kilometers and a summit that towers more than 20 kilometers above the surrounding plains. So 3 times higher than the tallest mountain on Earth. Yan. Which is what? Which is very big, di ba? So Olympus Mons has very few impact craters. Its present surface cannot be more than about 100 million years old. It may even be much younger. Some of the fresh-looking lava flow might have been formed 100 years ago, or 1,000 or 1,000,000, but geologically speaking, they are quite young. This leads geologists to the conclusion that Olympus Mons possibly remains intermittently active today, something future Mars land developers may want to keep in mind. So, they say that Olympus Mons might be active even for now, even in the present. And next one is the Martian cracks and canyons. So the Tharsis Bulge has many interesting geological features in addition to its huge volcanoes. In this part of planet, the surface itself has a bulge outward forced by great pressure from below, resulting in extensive tectonic cracking of the crust. Among the most spectacular tectonic features on Mars are the canyons called the Valles Marineris. So, ito yan. Valles Marineris. So, as we can see, napakalaki niya, no? Napakalaki niya. Ito yung planet. Napakalaki. So, they extend for about 5,000 kilometers, nearly a quarter of the way around Mars. So along the slopes of Tharsis Bulge, the main canyon is about 7 kilometers deep and up to 100 kilometers wide, large enough for the Grand Canyon of the Colorado River to fit comfortably into one of its seed canyons. So viewers of the movie The Martian can see a recreation of these canyon lands, as the film here takes a long trip through a spectacular and somewhat exaggerated presentation of this part of Mars. So this have a movie. If you want to see it, or if you want to view it, you can see the movie The Martian. Okay. So while the Tharsis Bulge and Valles Marineris are impressive, in general, we see fewer tectonic structure on Mars than on Venus. In part, this may reflect a lower general level of geological activity, as would be expected for a smaller planet. But it is also possible that evidence of widespread faulting has been borne by wind deposits, sediment over much of Mars. Like Earth, Mars may have hidden part of its geological history under a cloak of soil. So that's why we can truly say that this is what Mars have, because some things happen, might be buried around the ground or over the ground. So let's talk about the view on the Martian surface. So the first spacecraft to land successfully on Mars were Vikings 1 and 2 and the Mars Pathfinder. All sent back photos that showed a desolate but strangely beautiful landscape, including numerous angular rocks interspread with dune-like deposits of fine-grained reddish soil. So, eto yun. The Viking 1, dito siya. Anditong part siya nagland. And from a photograph, Ito siya. Ito yung nakita niya. This. So which is, and the Pathfinder. Dito siya nagland naman sa Mars. And ito naman, yung ano niya. Otis. And the Vikings too. Viking too. Hindi siya sa may taas. Sa may North Pole. Ito na. So, 3 Martian landing sites. The Mars Landers Viking 1 in Greece. So, this is Greece. Pathfinder in Ares Valley. So, this is the Ares Valley. And Viking 2 in Utopia. So, as you can see, they are more like Earth, since there's full of rocks. So all photograph their immediate surroundings. It is apparently from the similarity of these three photos that each spacecraft touched down on a flat, windswept plain littered with rocks ranging from tiny pebbles up to meter-sized boulders. It is probable that most of Mars looks like this on the surface. So there's a high probability that most of its surface look like the same as this. Okay. And during the winter, the Viking 2 also photographed water frosts deposits on the ground. We make a point of saying water frost here because at some location on Mars, it gets cold enough for carbon dioxide dry ice to freeze out of the atmosphere as well. So, ito yung Utopia. So, makikita natin yung difference. Ito yung Utopia which happened water frost. Medyo nag-ice yung mga wet part niya. Nakita natin. So, sa Mars pa din to. So, the most of the winds measured on Mars are only few kilometers per hour. However, Mars is capable of great windstorms that can shroud the entire planet with wind-blown dusts. Wind on Mars plays an important role in redistributing surface material, shows a beautiful area of the dark sand dunes on top of lighter material. Much of the material stripped out of the Martian canyons has been dumped in extensive dune fields like these, mostly at high altitude. So this high-resolution photo from Mars Global Surveyor shows the dark tracks of several dust devils that have stripped away a thin coating of light-colored dust. Ito yun. Nakikita natin. This view is of an area about 3 kilometers across. Dust devils are one of the most important ways that dust gets redistributed by Martian winds. They may also help keep the solar panels of our rovers free of dust. These wind-blown sand dunes on Mars overlay a lighter sandy surface. So, ito yan. This wind-blown. Each dune in this high-resolution view is about 1 kilometer across. Yan. Across. So, next. Atmosphere and clouds on Mars. So, we're going to discuss about the atmosphere and the clouds. Of all the planets and moons in the solar system, Mars seems to be the most prominent place to look for life. Both fossil, microbes, and we hope some forms of life deeper underground that still survive today. So, we hope that Mars has something that have life. Anything? But where and how should we look for life? We know that the one requirement shared by all life on Earth is liquid water, but Mars is, we might not sure that if it has liquid water, H2O water. Therefore, the guiding principle in assessing habitability on Mars and elsewhere has been to follow the water. So, follow the water. So, if you want to find life, just follow the water, because most of the civilization and most living things depends on water, so they followed water. So that is the perspective we take in this section, to follow the water. on the red planet, and we hope it will lead us to light. Yun. So, the atmosphere of Mars today has an average surface pressure of only 0.007 bar, less than 1% that of Earth. So Martian air is composed primarily of carbon dioxide, which is 95%, with about 3% nitrogen and 2% argon. So it didn't have an oxygen. It may have an oxygen, but it has less percent maybe an oxygen. That's why it's hard to find water in this area. So while winds on Mars can reach high speed, they exert much less force than wind of the same velocity would on Earth. Because the atmosphere is so thin, the wind is able, however, to loft very fine dust particles, which can sometimes develop planet-wide dust storms. Although the atmosphere contains small amounts of water vapor and occasional cloud of water ice, liquid water is not stable under present condition on Mars. Several types of clouds can be formed in the Martian atmosphere. So first, uh, there are dust clouds, which is discussed about. Second are water ice clouds. Similar to those on Earth, these often form around mountains just as happens on our planet. So finally, the CO2 of the atmosphere can itself condense at high altitude to form hazes of dry ice crystals. Yan. Dry ice crystals. And next is we will talk about the polar caps. Through a telescope, the most prominent surface features on Mars are the bright polar caps, which change with the season similar to the seasonal snow on cover Earth. So we do not usually think of the winter snow in northern latitudes as a part of our polar caps, but seen from space. So the thin winter snow merges with Earth's thick permanent ice caps to create an impression much like that seen on Mars. So this is a composite image of the North Pole in summer. So ito yun, in Mars, obtained in October 2006 by the Mars Reconnaissance Orbiter. It shows that mostly water ice sheet residual cap sitting atop light tan-colored layered sediments. Note that although the border of this spot is circular, yun, it shows only a small part of the planet. So, ayan, ito. Kita naman natin yung mga ice caps, mga polar caps. Okay. It looks like it has many ice things. Here we see a small section of the layered terrain near the Martian North Pole. So, ito. There's a mound about 40 meters high that is sticking out of a tree in the center of the picture. So, ito yan. It's a mound. You can see. So, the seasonal caps on Mars are composed of not of ordinary snow but of frozen CO2 dry ice. These deposits condense directly from atmosphere when surface temperature drops below 150 Kelvin. The caps develop during the cold Martian winters and extends down to about 50 degrees latitude by the start of the spring. And next is the Phoenix spacecraft. So you can know that the Phoenix spacecraft landed near the North Polar Cap in summer. Controllers knew that it would not be able to survive a polar winter. Will not be able to survive a polar winter, but directly measuring the characteristics of the polar region was deemed important enough to send a dedicated mission. The most exciting discovery came when the spacecraft tried to dig a shallow trench under the spacecraft when the overlying dust was stripped off they saw a bright white material, apparently some kind of ice. So after the spacecraft digs in the ground, they find the white material, maybe um, maybe ice, apparently some kind of ice. So from the way this ice eliminated over the next few days, it was clear that it was frozen water. So it has water on Mars. So evaporating ice on Mars, we see a trench dug by the Phoenix lander in the North Polar region. Okay, Martian days apart in June 2008. So if you look at the shadowed region in the bottom left of the trench, so eto siya. So you can see 3 spots of ice. So eto, yung mga 3 spots siya ng ice, which is we can see on the right side. Kasi sublimate na siya. Yon. And next is the channels and gullies on Mars. Channels and gullies on Mars. Although no bodies of liquid water exist on Mars today, evidence has accumulated that rivers flowed on the red planet long ago. Two kinds of geological features appeared to be remnants of ancient water courses, while a third class, small gullies, suggests intermittent outbreaks of liquid water even today. In the highland equatorial plains, there are multiple of small, sinuous piston channels, typically a few meters deep, some tens of meters wide, and perhaps 10 or 20 kilometers long. They are called run-off channels because they look like what geologists would expect from their surface run-off of ancient glaciers. So, this is the first one, the run-off channels. So, ito yun. Run-off channels. Yun. The first one, water-related features. So the second set of water-related features we see are outflow channels. So are much larger than the runoff channels. Ito. Napakalaki niya. The largest of these, which drains into the Crease Basin where Pathfinder landed, are 10 kilometers or more wide and hundreds of kilometers long. Many features of these outflow channels have convinced geologists that they were carved by huge volume of running water. So, makikita naman natin, parang napakaraming running water yung dumaan. So, far too great to be produced by ordinary rainfall, where could such flood water have came from? So, maybe merong water sa underground or beneath it. But as we can see, this is the outflow channel caused by the outflow channels. And next is the third type of water feature, the smaller Gullies, was discovered by the Mars Global Surveyor. The Mars Global Surveyor's camera images achieve a resolution of a few meters, good enough to see something as small as a track or bus on the surface. On the steep walls of valleys and craters at high latitudes, there are many erosional features that look like gills carved by the flowing water. So these gills are very young. Not only are there no superimposed impact craters, but in some instances, the gills seems to cut across recent wind deposit dunes. Perhaps there is liquid water underground that can occasionally break out to produce short deep surface flows before the water can freeze or evaporate. So ito yan, yung gills. Additional evidence that the dark streaks called by the scientists recording slope lineae are caused by water was found in 2015. When spectra were obtained of the dark streaks, these show the presence of hydrated salt produced by the evaporation of salty water. So if the salty water is salty, it could remain liquid long enough to flow downstream for distances of 100 meters or more before it either evaporates or soaks into the ground. However, this discovery still does not identify the ultimate source of water. So, they find the dark streaks. Ito yun. Ito yung itsura ng mga dark streaks in the soil. Okay. And the ancient lakes and glaciers. The rover spirit, opportunity, curiosity, and perseverance that have operated on the surface of Mars have been used to hunt for additional evidence of water. They could not reach the most interesting sites, such as the Gullies, which are located on steep slopes. Instead, they explored sites that might be dried out lake beds, dating back to a time when the climate on Mars was warmer and the atmosphere is thicker, allowing water to be liquid on the surface. The Curiosity rover landed inside Gale crater, where photos taken from orbit also suggested fast water erosion. It discovered numerous sedimentary rocks, some in the form of mudstones from an ancient lake bed. It also found indication of rocks formed by the action of shallow water at the time the sediment formed. So this is the fissure photographed by the Curiosity rover, showing an ancient lake bed of cracked mudstones. Yan, yan siya. And geologists working with the Curiosity rover interpret this image. So ito yung second image. Rover interpret this image of cross-bedded sandstones in Gale crater as evidence of liquid water passing over a loose bed of sediment at the time these rock formed. So ito yun. And the third feature is the ice bands. 100 tall are visible in blue in a cliff face on Mars, suggesting large deposit of frozen water buried just a few meters below the surface. So, ito yun. Parang nga siyang water, frozen water. 100 meters tall are visible in blue cliff face on Mars. So, blue indicates water. So, it may be frozen water. So, the climate change on Mars. So, we presume that like Earth and Venus, Mars probably formed with a higher surface temperatures thanks to the greenhouse effect. But Mars is a smaller planet and its lower gravity means that atmospheric gases could escape more easily than from Earth and Venus. So as more and more of the atmosphere escaped into space, the temperature on the surface gradually fell. Eventually, Mars became so cold that most of the water froze out of the atmosphere, further reducing its ability to retain heat. The planet experienced a um, sort of runaway refrigerator effect, just the opposite of the runaway greenhouse effect that occurred on Venus. Probably this loss of atmosphere took place within less than a billion years after Mars formed. The result is the cold, dry Mars we see today. So, Mars is likely to experience long-term climate cycles which may be caused by the changing orbit and tilt of the planet. At times, one or both of the polar caps might melt, releasing a great deal of water vapor in the atmosphere. Perhaps an occasional impact by a comet might produce a temporary atmosphere that is thick enough to permit liquid water on the surface for a few weeks or months. So some have even suggested that future technology might allow us to terraform Mars, that is, to engineer its atmosphere and climate in ways that might make the planet more hospitable for a long-term human habitation. So imagine that even though Mars is like this, the scientists or the people are planning to engineer it, to change it to a more fitting planet for human beings. The search for life on Mars. So if there was running water on Mars in the past, perhaps there was life as well. Could life in some form remain in the Martian soil today? Testing this possibility, however unlikely, was one of the primary objectives of the Viking landers in 1976. So, finding life is primary math, so to say. They didn't have even a clue, didn't get a clue. These landers carried miniature biological laboratories to test for microorganisms in the Martian soil. Martian soil was scooped up with a spacecraft long arm and placed into the experimental chambers where it was isolated and incubated in contact with a variety of gases, radioactive isotopes, and nutrients to see what would happen. The experiments looked for evidence of respiration by living animals, absorption of nutrients offered to organisms that might be present, and an exchange of gases between the soil and its surrounding for any reason whatsoever. A fourth instrument pulverized the soil and analyzed it carefully to determine what organic carbon-bearing material it contained. There is no reason to think that life could not have begun on Mars about 4 billion years ago. At, at the same time, it started on Earth. The two planets had very similar surface conditions then, thus the attention of scientists has shifted to the search for fossil life on Mars. One of the primary questions to be addressed by future spacecrafts is whether Mars once supported its own life forms, and if so, how this Martian life compared with that on our planet. Future missions will include the return of Martian samples selected from sedimentary rocks at such sites that once held water and thus perhaps ancient ancient life. The most powerful searches for Martian life will thus be carried out in our laboratories here on Earth. And Venus, Mars, and our own Earth form a remarkably diverse triad worlds. They're amazing. Although all three orbit in roughly the same inner zone around the Sun, and apparently started with about the same chemical mix of silicates and metals, their evolutionary paths have diverged. So they have different evolution. As a result, Venus became hot and dry, Mars became cold and dry, and only Earth ended up with what we consider a hospitable climate. We have discussed the runaway greenhouse effect on Venus and the runaway refrigerator effect on Mars, but we do not understand exactly what started these planets down these separate evolutionary paths. Was Earth ever in danger of a similar fate? So, or might it still be diverted onto one of these paths, perhaps due to stress in the atmosphere by human pollutants? So, can it happen? One of the reasons for studying Venus this Mars is to seek insight into this question. So that's one of the purpose of studying the Venus and the Mars. Some people have even suggested that if we understood the evolution of Mars and Venus better, we could possibly reverse their evolution and restore more Earth-like environments. While it seems unlikely that humans could ever make either Mars or Venus into a replica of Earth, considering such possibilities is a useful part of our more general quest to understand the delicate environment balance that distinguishes our planet from its two neighbors. In Cosmic Sample and the Origin of Solar System, we return the comparative study of the terrestrial planets in their divergent evolutionary histories. So I think that's all. So, so So thank you for listening and goodbye.